Thank you very much. So my name is Masayoshi Kobayashi. I'm from NEC, and I'm also a visiting scholar at Stanford University and working on OpenFlow projects since its beginning. So there's a large team working on this technology, design, develop, and the deployment and demonstrate in our campus. And we also funded by many companies, including networking providers such as Deutsche Telekom, NTT Docomo, and the vendors like HP and the NEC and Cisco and Xilinx. And we also work closely with Google, also many vendors. So basically, there's a large, significant activity happening in Stanford as well as outside of the Stanford. Okay. So we think internet is closed for innovation.
Can you speak up a little louder? It's actually screen. Yeah.
Screen? Okay. So we think the internet is closed for innovation. What does this mean? So internet is designed by philosophy so-called the end-to-end principle, and it basically says make the network core as simple as possible and leave as much space for the future innovation. But that's not true. So what's happening is if you take a look at the modern router, it consists of the specialized packet hardware and the proprietary operating system and application. Here, application means routing, management, mobility, management, access control, that kind of stuff. And the software part consists of millions of lines of source code, and it implements 5,000 of RFCs, and it's a great barrier to the entry. And for the hardware part, it's a huge number of gates, and it's bloated, and it's power hungry. So it's opposite to the end-to-end philosophy. It's actually many complex functions are baked into the infrastructure, and it ossifies the process of innovation. And one of the data center providers says it's an industry with a mainframe mentality, so it doesn't try to make innovation happen. The another problem is the standardization process. So if an innovator come up with a very simple idea, and if he want to make an impact in the real world, he has to go to the standardization process, and he need to do some standardization 10 years. The simple idea becomes something very different from the original idea, and nobody wants to implement it. There's lots of examples. So this is also ossifies the process of the innovation. Okay. So the software-defined networking try to change this situation. So this is the current internet. As I told, it's consists of closed boxes. So we open this and remove the operating system to run somewhere in the network on the server, and also remove the application and run on top of this networking operating system. So this is the architecture of the software-defined networking. And the key to the success is we need a very simple open interface to the hardware. And we also need at least one good operating system that should be extensible and possibly open source. And we also need a well-defined API. And if you look at this, it's very, very similar to the PC architecture. There's a x86 very open and solid interface to the hardware. And there's a Linux, it's extensible open operating system. And the POSIX API, so it's very well-known, well-defined API to innovate on top of it. And OpenFlow defines this interface to the hardware. Let me explain what OpenFlow is. So if you look at the modern router, they consist of a hardware forwarding table. And this dictates where to forward the packet based on the packet header. And they also have a software control part. So OpenFlow doesn't change hardware. It just simply opens up the interface to this hardware table. So with this interface, you can change the hardware forwarding table. So you have basically a full control how packets are routed in the network. So this is OpenFlow. Okay. And with OpenFlow specs define what's the interface in between the external server and the switch. So this is so that's the software-defined network. And naturally, we can have a virtualization, like a PC. So with this virtualization and some isolation, you can run a multiple operating system as well as multiple applications. So this accelerates the innovation in the innovation. So the consequence is more innovation comes to the network services, and the operators or owners of the network or researchers like you can innovate on top of the network. And there's many examples. Even in Stanford, we have lots of research running on top of this. And we could have we lower the barrier of entry, and there should be a more healthier market, and new players comes into this OpenFlow SDN market. Okay. And this is not just a dream of the researchers. So lots of vendors started supporting OpenFlow, including many different market segments, including wireless, circuit switch, and enterprise and core network. And of course, the support level of the support is different. Some vendor is just a prototype, but vendors like HP, NEC actually selling the OpenFlow switches as a product. And we try very hard to deploy this in the world. In the US, a chip explained as a Genie Spiral 2, we have 8 universities plus 2 national backbone deploying OpenFlow. And the EU and Japan have a similar project. And as far as we know, there are 6-8 trials spanning 13 countries right now. Okay. So its ecosystem is coming together. There's an interest from academy as well as providers. And as a consequence, lots of vendors start supporting OpenFlow, including wireless to the circuit switch and enterprise. And the chip vendor is also interested in. And there's a new class of vendors coming, like Nicira. They create a OpenFlow control software. So we have this ecosystem right now. Okay. So now I try to explain what's the implication to the wireless mobile networks. So cellular mobile network is a phenomenally successful infrastructure, but it's also closed for innovation. What does this mean? So there's abundant wireless networks available, but it's closed and unavailable, typically unavailable for us. So we like to make use any wireless network and many networks simultaneously. That's our goal for cellular mobile networks. Okay. So this explains the situation. So if you're a mobile device, at least you can see a 10 to 15 wireless tower or lots of wireless networks, but typically not available for you. You only use say contracted networks, like Verizon or AT&T, and it's very hard to do a seamless mobility. Okay. So the question is why I cannot use all of these wireless infrastructure around me. And ideally, we like to access to all the infrastructure at the same time, and move freely amongst all of the networks, all wireless networks. And we like to maximize the user choice and allow innovation instead of closing the infrastructure. Okay. So OpenFlow SDN enables this concept, okay, because they provide a shared packet infrastructure, and as I told you, they take the intelligence from network and running on top of it. So we can create a AP, it's very dumb, and you have a full control of how packets are routed. So with this, you could use the technology agnostic handover and seamless handover among the infrastructure. And we could have lots of experiments on top of it. And at Stanford, we created a wireless platform. It's called OpenFlow Wireless. And that consists of Wi-Fi and WiMAX heterogeneous network and some virtualization layer that virtualizes not only the flow table, but also some part of the wireless resources. And we can run multiple controller on top of it. And we provide this software suite to everybody. Okay? And we also deploy this technology at Stanford. So we have 80 plus wireless APs across School of Engineering. And we have 2 WiMAX base stations. And there's real switches running on. And we plan to deploy, so we work closely with Clearwire to borrow some wireless spectrum to do the WiMAX service in the School of Engineering. And we plan to use Ratogras Open WiMAX software stack to virtualize WiMAX base station. And we did some demo in the previous Mobicon. We try to show, so it's a tri-casting, comparing tri-casting and the unicasting over Wi-Fi and WiMAX. So with unicasting, the video streaming is glitchy, but if we can use the WiMAX and the Wi-Fi simultaneously, we can get a better streaming performance. And we also work with Genie to deploy this wireless technology. So Stanford and Ratogras will have a WiMAX Wi-Fi infrastructure, so researcher can do an experiment on top of it. And we expect more university deploy this technology. Okay. So this concludes my talk. So cellular mobile network is a mainstream network infrastructure for billions of users using every day. And it's a dominant access technology. And I'm not a wireless researcher, but from my point of view, we don't see much innovation on this cellular and mobile area, like other than the other exotic wireless areas, such as wireless mesh or delay tolerant. But with OpenFlow SDN, we can have a way to innovate on top of it. So why not try innovating on this fantastic infrastructure?
Thank the speaker.
Yeah, it's not clear to me how OpenFlow supports seamless mobility. Because in order to support mobility, you have to attach to an access network, right?
Mm-hmm.
And then you change your attachment point.
Yeah.
So how does OpenFlow address that problem?
Okay. So with OpenFlow, Wi-Fi, WiMAX, say 3G, whatever, any base station is like just changing the packet into the wireless. And from that point, it's just a packet network. So you can just change the packet routing of the packet, and feed the packet into any base station. So you have a uniformed API to the network to do the seamless handover. Is this clear?
So is there a paper or something to describe this design?
Yeah, we have a paper in Mobicon, and we also have a paper in this year's SIGCOM. It's a workshop called, SIGCOM workshop, we have a paper. Yeah, and we also have a web page. Okay, if you go to this page, there's a wireless section, and you can download the software to try out this stack. Yes.
One quick comment, I think. I mean, the thing that you're talking about, Wi-Fi, WiMAX, and or even the notion of having generic wireless access interfacing to IP network.
Yes.
Is already going in that direction, having a flatter architecture, more IP-based architecture. Or even the Wi-Fi, WiMAX handler already is demonstrated in the industry. So I don't understand why you need OpenFlow to enable all this kind of stuff. What is so special about OpenFlow that those things can't be otherwise done? Because the world is already going towards IP-based radio access. Right?
Yeah, but so if you come up with a new handover mechanism, you cannot implement in the current network. For example, I think my understanding, Wi-Fi, WiMAX, the handover only happens at gateway point. You cannot use the WiMAX, Wi-Fi at the same time, for example.
One
basically you said that network is close to innovation, but and the barrier to entrance is very high.
Hi.
This
Yes.
is deliberately by this. It's actually was designed in such a way that actually make the barrier so high that actually to conceptually to prevent competition.
Yeah. So,
So,
from the industrial point of view, that's right. Yeah.
So actually, so basically you ask to go to vendors or service providers, come and say, basically we want to give some sort of new technology is great, enable innovation, but it actually open a lot of competition for you.
Yeah. Yeah.
So question
Okay.
is, what is the reason to go to this direction?
Actually, this started from the data center. Data center users actually wants to innovate on top of it. They don't want to just use the vendor provided software. They like to change it. So there's some new provider have a real incentive to do this, and they can differentiate the other vendor, other service provider, and the similar thing begin to happening in the cellular and the real wire network service provider. So the industry is getting changing.
So we'll do one more question and then we'll leave him for questions.
Yes.
So I have a very short comment in response on the statement you made that there is a little innovation in the traditional cellular side of the wireless, much less the network and such. Actually, I don't think it is true. Actually, cellular innovation goes a little bit low in the stack. It's MAC layer and physical layer.
Yeah, I agree.
Handoff, so you didn't touch on the RF. There is a radio airlink portion of the handoff. It's very complex, and if you follow the standards, you see innovation is alive there.
I would just add on that, if you look at the literature, particularly Japanese literature, they studied the handoff problem quite extensively, and they're still studying it. And the B3G networks is the one that they were studying. Yeah, I was just going to add that I would also agree that at the networking level, that
Yeah, I agree.
there, particularly in the Japanese literature.
Like internet, in the MAC layer 2 area, there's an innovation. But including routing area, it's very difficult to innovate on top of it. You cannot just change the routing. You have to go through the standardization process to implement your idea.